This is chapter 6, problem number 31. The lucky number for this problem is number 7. Okay, so what it said is there is a skier that coming down from an incline or decline at an angle of 8 degrees. Okay, so this person, instead of a person, I'm going to just put an object to represent that person. This one is going on a frictionless surface. The height over here is given is 105 meters. Okay. The question asks, what would be the velocity when it comes to the bottom over here? Okay, so at the beginning, it's not moving. When it's not moving, so V initial over here, V initial is equal to 0. Over here, we're looking for what V final is. So this problem has to do with the conservation of energy. When it is on top over here, what is the kinetic energy? V equal to 0, velocity equal to 0, kinetic energy is equal to half mv squared. When v is 0, the kinetic energy is 0. So at the beginning, initially, the kinetic energy is 0. How about the potential energy due to gravity? Potential energy is equal to mgh. In other words, the total energy, that means the kinetic energy and the potential energy at the beginning, it will be equal to m times g times h because the kinetic energy is 0. Over here, that means m g h at the beginning. Since energy is conserved, so it will be equal to the total energy at the end over here. At the end over here, what is the potential energy? Potential energy is equal to mgh. Now the h is equal to 0. That's why this term is gone. What about kinetic energy? Yes, because there's a final velocity over here. So potential energy, mgh, is gone, plus half mv final square. If you look at this one, the m can be cancelled out on both sides. Okay, so v final, so multiply 2 by both sides, v final will be equal to square root of 2 times g times h. Okay, so what you need to do is just plug the number into it, equal to 2 times 9.8 times 105. If you use the standard unit, then you don't have to worry about this unit. So 2 times 9.8 times 105, and then take a square root of it. I got 45 meters per second. Okay, if you look at this one, it's independent of the mass. Okay, that means it doesn't matter how heavy this object is over here. At the end, as long as the height is 105 meters, then at the end over here, the final velocity is the same. If you look at this formula, it's independent of the angle or the way of the path. Okay, if you make it like this, if it's 45 degrees, okay, then at the end, the velocity is the same. Based on the formula over here, so it's independent of the incline or decline angle. It's independent of the pathway. Okay, the lucky number for this problem is 7.